हेलो एवरीवन। कैसे हैं सब? हेलो हेलो हेलो। लेट्स वेट फॉर 2 to 3 minutes. कैसे हैं सब लोग? आई होप सब बढ़िया होंगे। सत श्री अकाल। बस मैं थोड़ा स्ट्रीम चेक कर लूँ। कैसे हैं सब लोग? आई होप सब बढ़िया होंगे। सत श्री अकाल। बस मैं थोड़ा स्ट्रीम चेक कर लूँ। हम्म तो मैंने जो फर्स्ट स्ट्रीम थी वो देखा मैंने। उसमें काफी सारा दिक्कत यही था कि that my words are not that clear और थोड़ा सा फास्ट फास्ट बोल रहा हूँ। like I have to be feel like streamer, थोड़ा सा और real रहना पड़ेगा। it will come, more clarity will come and everything will come. So yeah, that is the thing. Let us start our day. So on the last stream मैंने बताया था आपको कि uh, okay, I have to use English. Okay. So in the last stream we talked about the introduction of this noise cancellation device, NCD, what we are calling it, and what we are aiming to make and how we are proceeding. Now the thing is that sorry for that. Now the thing is that um, we have a solution of masking the sounds, which is doing reasonably good amount of work. But we have to find something else. Like we have to find the way out to reduce the construction noise and humming noise, so that we can tackle all the types of frequencies at one time. So yeah. So our action item the last time was to tackle the construction noise and humming noise. So let me just check where I left ChatGPT last time. Yeah, so in this thing, so what I was trying to do, so there is a transformer in my society and there is some constant noise coming from it. So what I was thinking, if the sound is constant, then I should be able to create a um, ANC algorithm which will listen to that sound and which will be able to completely nullify that sound or to some extent. So actually ANC works on your ear, doesn't cancels out sound, like cancel out, like don't kill it, don't kill the sound. Instead it's just it will not be audible to the ear. That is the thing. So worked out, then ChatGPT says me like there is a lot of factors in that. Like your exact mental model, you're imagining this loop. Transformer produces a constant humming wave. Microphone near ear hears it. So that converts. So the ChatGPT was saying that Bluetooth delay is 100 to 500 millisecond. Why can't the algorithm learn that delay and compensate? So that is the thing that ChatGPT is. AI, or I was thinking to apply anything to that. So I asked him to explain me mathematically, and then he explained me mathematically, which I understood a bit, but not that much. So yeah. I want to add any animal future productions I had and changes some way to say this. Listen, so currently, So, yeah, yeah, geometry is fixed. It won't geometry fix like I told you in the last video. Cancel sum, not one way that multiplies instability. Speaker little speaker very close. Control constraints the life efficiency comes from trying to what blows next latency measures actual Bluetooth round trip delay compared to wave period. See the mismatch numerically. Yeah, we can validate this theory that Bluetooth has. We'll never believe ChatGPT blindly. Ask ChatGPT to uh, tell a test or something, and from that test you just concluded mathematically that yeah, this is not possible. So yeah, so what next we can do? Hmm. So our aim is to put some device on the window itself. Okay. Our aim is to some put device on the window itself, and from the window, the noise will get cut off. So if we are putting some device on the window, then there would be suppose two or four speakers on each edge of the window. There would be two or four speakers with microphone on each edge of window, and all of them are simultaneously listening and producing the inward wave according to their analysis. This is the thing. This is one thing that we are trying to do. So to think about it, what we can do? Hmm, how to move further? So the sound wave is coming. So window dot model is kind of that only, I guess. And let me ask directly to ChatGPT. Let's do this. So consider the window as a listener, like window is listening. So if a sound doesn't pass through the window or passes through window with less energy or less decibels, then we got successful experiment. Uh, Moreover, I don't know. This I think we should still focus on that transformer experiment. I want to test that thing that works or not. Because currently it's not working at all. Oh no, into this. Because if you know, like if I know with some experiments or with some data that there is a Bluetooth round trip latency of some X milliseconds, and there is some other type of latencies due to which ANC algorithm is not able to cancel out the noise, then AI should try to tweak some AI should try to tweak some of the variables, and maybe it could work. I don't know about the AI efficiency here, but the thing is that only key I want to make it happen somehow. It should make it happen. And Yeah, it's very tough in open environment. What I'm saying, like I'm standing in open surrounding where a transformer is kept, and and we have to, and some sound is coming. Now the sounds are coming like waves, so sound could be coming from various directions, like all the directions. Like it's not mandatory that sound is coming from the transformer only. So sound is coming from transformer to some wall, it's bouncing from the walls, and all that things are also happening there. But the way the source from which the inward wave would be producing would be nearby my ear for now. Suppose would be held at one position and one fixed position. So that would be the one fixed position, and that will be very, 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 very close to the microphone, which is recording the noise. I just want to make it possible somehow using AI or using some own advanced algorithm like ANC, advanced ANC, something like that, which could cancel out these factors. So I wanted to brainstorm and think deeply how we can make this possible. So yeah, let's just try to think about it. I guess ChatGPT has reached its limitation. So in one chat, if it's not producing results, uh, I prefer to move to a new chat or completely new AI like Gemini or something else. So yeah, think like session of filmmakers and visual expert what can be bent and what cannot be bent, and where AI actually helps versus where it fundamentally cannot. I'll structure this clear so it doesn't become hand wavy. First, let's log the experiment you want. You want the scenario to work. A transformer produces a constant hum. You stand up in a mirror. Your mic is very close to your speaker, very close to both of fixed related to an algorithm to this continuously automated. Over time, constellation should not explore. This single is a single point ANC experiment. That's already a very important section and a good one. What part of the actually illustrates the assumptions where I transform stationary frequency contains an environment, phase coherence exists over time, mic and speaker can be fused, we can only care about one mere position, we don't need global silence, all of this. These are reflections, multipath and open geometry, latency variation, these are things where speed of sound, casualty, control when selective delay is too loud. This is where physics draw lines. Most importantly, keep thinking in terms of the algorithm research is wrong and try again. This but completely missing also ANC is not error correcting like ML training. It's a phase locking, like a PLL, phase locked loop that changes how we think completely. Think of it as a phase lock system. Forget cancel noise for a moment. Think instead the algorithm tries to lock onto the phase and frequency of the hum. Mm. Think, 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 think. Just give me 1 second, guys. Yeah, we're back. Thing is, the algorithm tries to lock onto the phase and frequency of the hum and emit an opposite facing. So it's not trial one, trial two, trial three. It is a continuous phase tracking. If phase lock is achieved, cancellation. So AMC is not some algorithm which learns. So it listens a sound, it emits a reverse sound, and that's it. Because it identifies a large unpredictable latency causing violations, log horizon prediction. Let's make this concrete with transformer. Typical transformer 50 Hz fundamental. Harmonics 100 Hz speed, 100 Hz speed, 10 seconds. If Bluetooth latency is 100 milliseconds, that's 10 full cycle. The phase you now can need now corresponds to sound 100 milliseconds ago. AI would have to predict phase 10 cycles into the future with reflections with it. But where transformers very stable, you might say, but the transformer cost is not critical, and this is strong because this is one realistic and one viable advanced approach to AI before. The approach is not classic NC. Predictive narrowband harmonic cancellation instead of reacting to mic error, radio identify dominant frequency, generate continuous period and the frequency phase log slowly. Narrowband varies the period is predictable, phase drift is slow, delay becomes less restrictive. Stability improves, dizziness reduces. This is not generalized, it's sound cancellation. Acceleration would actually regular frequency use a 50, log into strongest peaks, internal oscillator, generate sine waves internally. Do not replay recorded audio. This avoids buffering delay, phase adaptation slowly adjusts based on micro schedule, small corrections only, gate adaptation keep gain low and bound and never chase silence speed. Frequency tracking it should not be. Will this give visually observation, not silence possible and noticeable dissection reduce pressure sensation reduce fatigue. This would be wow, it's calm, not the sound band. Use recorded way instead of oscillator head large if you want to continue the dynamics. So now ChatGPT has given something to do on, and I'm trying to protect it from collapsing into pushing it like physics guarantees failure. Not wrong to think this should be possible somehow, but how matters more than how badly you want. Some new opinion is only when you stop chasing noise and start looking onto structure. If you want next, I can design the exact harmonic cancellation experiment. Try to learn electricity or code, help you push this absolute physical limit, or show how this insight translates into real productivity. So yeah, let's try this harmonic cancellation experiment. Uh, give me the best possible thing that you can. I still want to use AI because AI is powerful, it can learn, it can do things. But if you don't want to bring AI on board, it's okay. Uh, let's start this exact harmonic cancellation experiment. And I wanted to perform it in open air only, not with some recorded voice or something. I will go near the transformer and would like to test it there. So yeah, yeah. So this is the thing. Let's try to build something like that. Because AI is powerful, it can learn. That is what machine learning and AI is the thing, because it can learn from the data, it can do things from the data. I'm not thinking that if someone put my device on the window on the first day, it will cancel out all the noise. It will learn throughout the day what noises are coming. It will do some analysis at the back end or somewhere, and on the next day it will get 1% better. On the second day it will get 1% better. So that's what I am thinking from my product. Let's see. Sorry. So yes, tool does some harmonic cancellation. Hmm. Yeah, so we'll try to do this experiment. Uh, but I have to stop this stream right now. I'm very sorry because I have to go somewhere. Uh, and obviously I can't do long streams for now. I'm not very prepared for it. It's a short 20 minutes stream. We'll try to do more streams, more longer stream. But yeah, so I will continue today in some time. So thank you for being there.